Suppose I increase the difference V1 minus V2 a lot. What will happen?
Okay.
What will happen?
So let us say, let us do the easy case. Let us put in DC voltages,
Correct.
right?
Correct.
So I'll remove this capacitor.
Yeah.
So what I will do, I will take this. Let me do one thing. I'll go to the next page because I want to modify this slightly. So I'm going to remove these capacitors and put DC voltage.
Yeah. Then even R1, R2 may not be required, no?
R1, R2 is not required.
Yeah.
Correct. So what I will do, I'll remove this also. Easy, no? Okay.
Yeah.
So, okay, this is the easy portion of the circuit. Okay,
correct.
Core portion of the circuit that we want to look at. So, what I am going to do, I am going to connect some DC voltage V1 and V2.
Yeah.
Okay, and you want to increase V1.
Yeah. So if they are same,
then no problem. You have current I0 through each side.
Correct.
Right?
V01 will be equal to V02.
Correct.
Output is 0.
Correct. So in fact, what I will do, we will just call these V1 and V2. I think that is easier.
Yeah.
VO1
V.
And VO2. Okay. So if I give V1 equal to V2, right? So then what happens is that everything is symmetric for all transistors. So then what will happen?
V01 will be equal to V02.
Correct. So the two currents will be I0, right?
Yeah.
V01 then will be equal to V02 will be equal to VCC minus I0 RC.
No change.
No change at all, right? And output will have, you will get identical outputs.
Correct.
No problem.
Anyway, it has to reject the common mode.
It has to reject the common mode. Correct.
Yeah.
Correct. So no
problem. So if I
no?
increase V1.
Now you are saying what happens if you increase V1, right? So V2 you keep constant?
We can decrease also.
You can decrease also.
Yeah.
If you want, you can decrease it.
Or
maybe what you could do,
we'll vary one at a time.
We'll vary one at a time.
Yeah.
Well, there are many ways of doing it. Maybe what you could do, no? You take it to, I'm going to increase it by some delta V. What I will do, I will symmetrically decrease this.
Yeah.
Right? In fact, I already know, I can tell you what will happen because I am now giving delta V differential input.
True.
Right?
Yeah.
Earlier I started with V1 equal to V2.
Correct.
So now I will get a fully differential, purely, the common mode is V.
Yeah.
Right?
Yeah.
So we'll call this equal to V.
Yeah.
Right? V plus delta V by 2 and V minus delta V by 2.
Common mode is V1 plus V2 by 2 is V itself.
Is V itself, nothing has changed. Common mode, I'll still have currents, no problem.
Correct. So now I note one branch it will increase a bit, other branch it will decrease a bit.
Correct. I will get some delta I and the other branch has to decrease, no?
Correct.
Because the sum of the two has to be 2I0. So one branch will, the side on which I add delta V by 2 will increase. The side on which I reduced the voltage by delta V by 2 will have minus delta I. Correct.
So if we keep on doing this.
So if you keep
delta
on doing
V, little bit more.
Little bit more.
So at some point it seems all 2I0 will go through one.
That is true.
Huh?
That is true. So what will happen? Suppose I large value, no? So it's no longer delta V.
Yeah.
Right? Right? That is the most extreme. this goes to 0 volts.
Yeah.
VCC and 0.
Correct.
Well, what will happen is the delta I would get larger and larger
Yeah.
until I'll get 2 I naught in this side
In one branch.
in one branch.
For that, we may not need to go up to VCC.
That is true.
Even before it will happen.
That is true. That is true.
Correct.
It may happen even before VCC.
Correct.
That is correct. So we'll just say V plus V large.
Yeah.
And we'll say V minus V large.
Yeah. Correct.
Okay.
So at that time, V01 will be VCC minus 2 I naught RC.
That is true. Correct. So then this would be VCC minus 2 I naught times RC.
Yeah.
And this side the current went to 0,
Zero.
it will just be VCC,
Correct.
right? Perfect. So the difference between the VO1 and VO2 would be minus 2 I naught RC. Correct. And the difference between the two currents will be 2 I naught. Right?
So now the current has fully switched from one branch to the other
To the other. Correct. And I could do the reverse also, no?
by
Giving V minus V large here and V plus V large here,
Correct,
I could
correct.
switch the currents completely.
correct.
That is true. So now it is almost, I remember when we did the common emitter amplifier,
Yeah.
we actually drew what will happen for output voltage as a function of input voltage.
Correct,
We
correct.
can do the same thing here, no?
Hmm.
So more looks like you will get something, the extreme values will be VCC and VCC minus 2 I naught RC.
Yes.
Correct. Correct. We said that was some inverter, no? Some kind of inverter.
Correct.
So looks like this is also some
Yeah,
kind of
yeah.
inverter, no?
Yeah.
Because you are getting, on one side you are getting VCC, other side you are getting VCC minus 2 I naught RC.
So
If you did the other way, you will get plus 2 I naught RC,
correct.
right?
So if output is high, it will be VCC.
Correct. If
Low
output is
will
low,
be-
it will be 2 I naught VCC minus 2 I naught RC.
Okay.
Correct. So you can get a logic gate between these two levels.
And we can ensure that this transistor will be in active region.
That is correct. You have to ensure that. Correct.
That may be already ensured because 2 I naught is, we can select in that
We can
way.
select in
RC
that way.
also.
Correct. We select I naught, 2 I naught and RC,
Yeah.
and this V large also.
Correct.
V large also.
If that goes beyond
That goes beyond, then it will not be valid.
beyond VCC minus 2 I naught RC, then that junction will become
Forward
forward
biased.
biased. So that's a problem.
Correct.
Yeah.
Correct.
So this can be a digital
This
logic
can be a digital
also.
logic also. Correct. Because if you give V plus V large on one side and V minus V large, you are getting minus VCC minus 2 I naught RC low on one side, high on the other. You interchange the two, you will get exactly opposite. So this can be used as logic as well.
So that is the family we were talking.
That is the family we were talking about. Correct.
ECL.
ECL. Correct. So you could make it emitter coupled logic.
Oh, emitter is coupled together.
Yes, correct.
Also very nice. So the same structure,
Yes,
I can use it as a difference amplifier. Huh?
correct. Or as a logic gate. So you do this if you are interested only in two levels, no?
Correct.
And VCC minus I naught RL.
And I heard this ECL is
Yes.
the fastest logic family.
That is correct. I
Huh?
believe so. That is correct. It's the fastest logic family. If you want to switch the gates at very high speeds, this is the fastest you can do. Correct. That's right.
So maybe this Q1, Q2 operation region, etc., can be designed properly with this 2 I naught RC and all that.
That's correct. That's correct.
So the fastest, because it also maybe the device understanding may be required. to
That's
know
right.
Why,
That's
why,
right.
Why it is fast.
That is correct.
Okay.
Right. I'll put it in. I'll put it in quotes. Fastest logic family.
Yes.
Right. So that they'll go and do study up a little bit more
Yes.
if they are interested in the logic aspect,
Yeah.
logic gate aspect.
Yeah. Yeah.